Thanks, Dr. Seisler, for that information. We look forward to it. Okay, students, let's learn a little bit more about rational numbers so you can determine your ratio of rest.
Numbers can be written in different forms, depending on how they're being used. We are going to look at 3 forms of rational numbers: fractions, decimals, and percents. One way to write a rational number is as a fraction. A fraction has a numerator and a denominator. For a rational number, both of these must be whole numbers, and the denominator must not be 0. The denominator is the number of equal parts you divide the whole into. The numerator stands for the number of pieces you are considering out of the whole. For example, Norbert is going to eat a pizza. Now the pizza is cut into 10 equal pieces. He eats 7 pieces out of the 10, so we can say he eats 7/10 of the pizza.
Even a whole number can be written as a fraction when you put it over the number 1. Now, any fraction with the same numerator and denominator is equal to 1. And if you think about it for a minute, it makes sense.
If Norbert had 10 slices in the whole pizza, that is the denominator. And if he ate 10 of them, that is the numerator. The resulting fraction would be 10/10, or 10 divided by 10, and that equals 1 whole pizza.
Another way of describing how much pizza Norbert can eat is by using a decimal.
To express a fraction as a decimal, we divide the numerator by the denominator. In Norbert's case, we divide 7 by 10, like this. We call this 7/10. Now, we can say that Norbert has eaten 7/10 or 7/10 of his pizza. There is still another way to express how much pizza Norbert has eaten, and that is using percent. Percent is a special fraction that is always based on 100. We can express any decimal number as a percent simply by multiplying by 100. 7/10 multiplied by 100 is 70%. Let's review. 7/10 equals 7/10 equals 70%.
Now that you know how to express rational numbers as fractions, decimals, and percents, try this example. Don't forget to look for equivalent fractions, too.
Norbert orders an 8-slice pizza and eats 6 of the slices. Show how much he ate using a fraction, a decimal, and a percent. Teachers, now might be a great time to stop the program as students work this out.
Welcome back. How did you do?
Norbert ordered an 8-slice pizza, so 8 becomes the denominator. He ate 6, so that is the numerator. Norbert ate 6/8 of the pizza. To find the decimal, we divide 6 by 8. The answer in decimal notation is 75 hundredths. Now, to figure out the percentage, let's multiply 75 hundredths by 100. Norbert ate 75% of his pizza.
Now, let's look at ratios.
A ratio is a comparison of 2 quantities by division. Because we know that Norbert ate 6 slices of pizza from the total number of slices 8, we would write this ratio as 6 eaten to 8 total. Ratios can also be written as fractions, like this: 6/8.
Now let's look at proportions.
A proportion is an equation stating that 2 ratios are equivalent. Let's compare how much pizza Norbert ate compared to how much Zot ate. The unit is a slice. Now we know that Norbert ordered an 8-slice pizza, but Zot wanted his pizza cut into 12 slices. We know that Norbert ate 6 slices. Zot eats 9 of his 12. Norbert's ratio of eaten slices to total slices was 6/8. What will Zot's be? That's right, 9/12. To see if these ratios form a proportion, we set them up like this: 6/8 equals 9/12. Next, we cross-multiply the denominators and numerators like this. If the answers on either side of the equal sign are the same, then the 2 ratios are proportional.
Now that we know Norbert has been well fed,
let's visit with students from Cole Middle School in Oakland, California. They're doing a classroom activity on decimals and percentages, along with some scientific observations on their sleep.
Hello, welcome to Cole Middle School. We're about to show you a cool activity that you can try with your class.
You can view and download this activity from the NASA Connect website. Our teacher gave us data sheets to collect information about the way we and our family sleep at night.
On the data sheet, we recorded when we went to bed, when we woke up, and how many hours we slept. Some of us also kept track of other members in our family. We collected this data for at least 1 week. We also recorded some observations about how we felt throughout each day. Using the logs, we made graphs to see if any patterns occurred in our data. Next, using the data, we figured out the average number of hours each person slept. Some of us noticed that younger kids in our families sleep a lot more than we do. We also noticed that some days we felt really tired and had a hard time getting out of bed. Next, we created another representation of our data, called fraction wheels. Like our graph, these wheels showed how much of our day was spent sleeping. Write this portion as a fraction and convert this to percent and then decimal. To make our fraction wheels, we used colored construction paper, pencils, compass, protractor, and scissors. We drew 2 circles and cut them out. One entire circle represents 24 hours in an Earth day.
Remember, the length of any planet's day is the number of hours it takes to rotate once on its axis.
Because there are 24 hours in one day, we divided one of our circles into 24 equal pieces. We used division to figure out how many degrees were in each piece.
Can you think of another way of making 24 equal pieces?
Next, we needed to make the slits that let us slip the 2 circles together, like this. Now we could see what fraction of our day was spent sleeping, and it was easy to see how fractions, percents, and decimals are the same.
Some of us also researched the length of a day on other planets.
For more information about this and other student activities, visit the NASA Connect website.
Awesome job. Well, we've seen how Cole Middle School conducted the activity. Let's return to Derek's challenge. Take it a step further and see if we can help Norbert out. Oh, my hams are talking to me.
Thanks, Jen. Okay, kids, you have learned how to set up ratios. Let's apply what we have learned to Norbert and Zot as they explore the other bodies of our solar system. We want to make sure Norbert and Zot get the right ratio of rest. On Earth, Norbert feels pretty good when he sleeps about 9 out of 24 hours, or 3/8 of the day, a lot like you. But if he wants to get the same ratio of rest when he visits Neptune, how much should he sleep? First, you will need to find out how many hours are in a whole day on Neptune. Next, we need to apply ratios and proportions. Remember, a ratio is a comparison of 2 numbers by division. In this case, we are comparing hours on Earth to hours on Neptune. The unit of measure is an hour, and a proportion is a statement that 2 ratios are equivalent. How many hours of sleep are needed on Neptune in order to create a proportion with the same Earth rest ratio? Teachers, now is a good time to pause the program. Let's see what you came up with. You should have set up a proportion that states 9 over 24 hours on Earth is equivalent to x over 16 hours. We use the variable x for the amount of sleep hours since we don't know the value yet. Next, we will cross multiply like this. Find the products on both sides of the equation and solve for x. X equals 6. In order for Norbert to sleep 3/8 or 9/24 of his day while on Neptune, he should sleep about 6 hours while on Neptune. Don't worry if you got this answer wrong. You can always try again.
Wow. 6 hours of sleep a night isn't enough to keep me healthy and performing at the top of my game. I know. Let's check back with RJ and see if he's found out any information on the circadian clock that might help Norbert in his travels around our solar system.